lots of pictures.
What?
There were lots of pictures. That was fun.
You like this? Pick the pictures?
Yeah.
Good. Well, here we are doing the work on page 789, topic 12.1. Okay, I'm going to help you with your homework.
Oh, yeah.
Question number 1. What is descriptive statistics? Do you know what it is?
Well,
But you know where to find it on
Yeah.
page 780.
yep.
And what does it say?
It's
Right in the middle of the page.
summarizing in a concise way the information collected.
So, descriptive statistics is summarizing collected information. Okay, I'm going to do some of this right now. Look around this classroom. Guess what? 2 out of 3 of the women in this classroom are wearing red. So, that's my descriptive statistic. I summarize collected information. I collected information on what color are the ladies in the class wearing, and I have 2 reds and 1 tan. Now, what's the second question?
What is inferential statistics?
And that's also on page 780.
Using methods that generalize the results obtained from a sample to the population and measure their reliability.
So, what I just did is I described what color clothing 2 of the 3 girls in the class are wearing. Now, that's just descriptive statistics, describing with numbers. 2 out of 3. Now, watch me do some inferential statistics here. So, I'm going to conclude that of all the women on campus this morning, in all of the classes on Calvary University classrooms, what am I going to conclude to generalize my findings to the whole population?
2/3 are wearing red.
That 2/3, 2 out of 3 of the ladies on campus today in all the classes being conducted are wearing red. You're not sure that's going to hold up, are you, Carissa? You're looking at that and going, I'm thinking maybe that is not going to be true. Well, the only way, do you have another class today?
Mm-hmm.
So, in your next class? So what will you do when you get to your next class to test out my theory?
Count the number of people.
You'll count the number of people wearing red, and if there are 9,
2.
Yeah.
what?
All 3 of us are in the next class.
Yeah.
Yeah, and if there are 9 women in the class, then what would we infer?
6 of them would be wearing
That
red.
6 of them are going to be wearing red. And if my generalization holds up, you go, whoa, he might be onto something here. If my generalization doesn't hold up, when you go to your next class, you'll say, well, his research is faulty. And it's like, well, what was wrong with my research? I described here, it's like, well, because you didn't have a big enough sample. See, that's what, it's making a generalization about a population inferring from a sample. And I only had a sample of 3 people to represent all the women on campus.
Mm-hmm.
And in a sense, when you go to your next class, you'll be looking to see if another sample bears out what we found with this sample. If it does, if you get to your next class, and that would be so cool, that would be so cool if there were 9 women in the class and 6 of them were wearing red.
Mm-hmm.
And then you go, I wonder if there's something to this. And so then when you go to chapel, you don't have chapel today. You go to the cafeteria, and before you sit down to eat, you stand up and you count how many women are in the cafeteria, and then count how many are wearing red, and probably counting the people in the cafeteria, that would just about be most of the population of students in class today, wouldn't it? So you'd have a big enough sample to make a stronger generalization. Can you see how much fun you can have with this, doing this kind of statistical stuff with little kids, collecting information? I mean, just what color shoes are you wearing?
Blue.
Blue?
Black.
Black? Tan? So blue, black, and tan. Now, see, and we say, okay, let's find out what happens in the next class. And you can just have fun with this stuff. At least I think it's kind of, so sometimes when you look at this, you go, what is all of this? Then you think, you know, we can have some fun with this, and we can start to understand what's going on. Question 3, another one of yours, says, what's the difference between a population and a sample? And what would be the answer to that question? The population, that's on page 782. The population, see, that's cool. When you read this before you get here, you think, I know I read that. What did it say? And you turn back, and so what's the population?
Well, it's like everybody.
That's exactly right. That's exactly what it is. It's the entire group. It's everybody in the group. So what's the sample?
It's like a selectively chosen group.
It's some of the group. You've selected some people from the group. I think that's on page 782. And you probably want to write this stuff down because you know you're going to have to know it for the test. And it's not the kind of stuff you're going to necessarily carry around in your head. So if you write it down and bring it with you, you'll be able to answer the question. But if you do enough of this with the little kids in your classrooms when you're teaching math, will they start to fix in their heads the difference between a sample and a population? Question 4. The shoe sizes of all the members of the University of California basketball team were collected and organized in a frequency distribution. You know what that is? A frequency distribution? That's on, where is that? What page is one of those on? They're so pretty. They're so cute. Where's the first one they have in here? There it is, page 783. See that little chart? Table 12.3, a frequency distribution. And 12.4 is another frequency distribution. And it's the same information as 12.3, it's just in a smaller table. They just group things differently. 12.3 has every score listed. 12.4 has 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 and 11. So you have a choice as to how you make a frequency distribution when you're making these things. Now, it says on number 4, the shoe size of all the members of the UC basketball team were collected and organized in a frequency distribution. So we would probably just list all the shoe sizes and then make a tally mark for every time someone with that shoe size comes up, and then add up the tally marks and get the numbers for the third column. We'll do one of those in a little bit and show you how it's done. But what they're asking for number 4 is, does this collected data, does this information I've collected represent a sample or a population?
It would be a population, wouldn't it?
That's right, because I took all the members of the basketball team and collected all of their shoe sizes. So that would be a population. Now, if I want to take that information and make a generalization about college basketball players all over America, then that would turn my population into a sample. You follow me? But basically, if I collected all the information from everybody on the team, then that's a population description. But I could collect information from all the students on this campus, and that would be a population description. But then if I made generalizations about other schools around the country, then it would become a sample that I'm using to infer about other schools. Does that make sense? Problem number 6. The students in a statistics class, took a random sample of 50 colleges and universities regarding student fees at the 50 institutions. So they took 50 colleges, and what did they do? Took a random sample. Does it say how many their sample was?
50.
They took a random sample of 50 colleges. Regarding student fees at the 50 institutions.
Mm-hmm.
So their sample is 50. They picked 50 schools. Is that what it says? And then they concluded that their own student fees were higher than at most colleges in the country. How many colleges in the country? You don't know. Well, I Googled it just to see. There are 529 public four-year colleges, 1,845 private four-year colleges, 1,670 public two-year colleges, and 596 private two-year colleges. Did they specify whether it was a two-year college or a four-year college?
Mm-mm.
Well, if it said colleges and universities, they're probably thinking four-year, aren't they? Wouldn't it be better if they would have said they picked a random sample of 50 four-year colleges and universities? Then wouldn't it be better if they would have said 50? Okay, is their college a public college or a private college? Does it say?
Nope.
If they wanted their statistic to be more valuable, to make it a stronger statistic, if they're a public college, then what should they have picked their 50 colleges from? Public universities?
Mm-hmm.
You follow that? If they're a private college, they should have picked private universities to draw their sample from. And then after they collected their information, they said, well, guess what? The average fee for these 50 colleges is lower than the fees are at our college. I'm going, well, okay, let's look at how you collected your information, and let's see if your inference about our fees are higher than most colleges in the country. Did you take most of the colleges in the country and use them for your population to get your sample? How would you do that? If it was a public university, and there are 629 of them, you would put the names of 629 colleges in a box and shake them up. And if you wanted your sample to be a random sample, you would reach in the box and pull out 50 of them and collect information from those 50. If you only took the 50 that were in the 3-state area where you live, then that doesn't represent all the schools in, what did they say? Most colleges in the country. Do you follow what's happening? When you do a random sample, you have to represent the whole population and then reach in there and pull out the number that's going to be your sample, which gets pretty complicated, but that's what you have to do if you want it to be a random sample. That's why that word random is very important. If it's going to be a random sample, and here's what random sample means. I think it's on page 782. It means that every college in the country has an equal chance of being selected as one of them that you collect information from. So every college in the country has an equal chance of being selected as one of the 50 that you're going to collect information from. Does that make sense? All right. So what's the population? 6A, first question, what's the population?
Whatever you just said, the 200.
See what it says there? When they said our fees are higher than most colleges in the country, their population was most colleges in the country. And what's the sample?
The 50 colleges.
The 50 colleges that they collected information from. So you have to look at what they're saying. Okay, who's that guy that keeps doing surveys on Christians in America, on churches in America, and he publishes his results and pastors get in the pulpit?
Ken Ham?
Have you heard him mention that statistics say
Like half the young people are moving out of the church or whatever?
half of the young people, and it's just like Christian young people are leaving the church in droves?
Uh-huh.
What is that guy's name?
Ken Ham.
Who?
I think it's Ken Ham.
I have no idea. I've heard that.
And see, when I hear these statistics, my first question is, because I've studied this topic that you're studying right now, is how did he get his sample? And how many people were in his sample? And did he include all the churches in America? That's a pretty broad spectrum of churches, isn't it? Or did he just only include churches where people carried their Bibles to church and they actually preached from the scripture in that church? And see, I don't know. And it seems like a lot of people just want to quote his statistics without asking, where did he get this information?
Mm-hmm.
I mean, I could go home and say, Nina, you know what? She goes, what? I say, 2/3 of the girls at Calvary are wearing red today. Is that amazing? She goes, what's the point? What are they doing? I said, I don't know. Maybe there's some kind of thing going on. But you girls will have a chance to check it out, won't you? It's like, guess what? Dr. Bonine's statistical analysis was flawed because he had too small of a sample. to represent everybody on campus. So that's why when you hear people quoting statistics, you need to ask how they get their sample, what population did they use, and did they get a random sample?
So I have a question.
Go ahead.
What does it mean in problem 5 when it asks about what is an implied population?
Okay, let's look at question 5. In a survey in USA Today reports that 29% of 1,006 households surveyed stated that their favorite shopping day was Saturday. Okay, so let's say I'm the guy at USA Today who did this survey. I surveyed 1,006 households, and I said, guess what? The favorite shopping day in America is Saturday. What's the implied population? The people in America? What if I would have said, guess what? The people who subscribe to USA Today their favorite shopping day is Saturday. So why did you say that? Because I used as my population subscribers to USA Today, and I randomly sampled 1,006 of them. Or maybe I just published my survey in USA Today, and I collected my information in Kansas City, Missouri. I collected 1,006 people out of the phone book. How would I do that? Get a phone book.
What is one of those?
And if it has 500 pages, then that means I would collect 2 names from each page at random. But then I said, guess what? Saturday is the favorite shopping day for all the people in America.
But that's not true because only 27%.
Yeah, and it's only 29%
I meant 29.
of the, 29% said Saturday was their favorite shopping day. Now, but your sample was from Kansas City, Missouri. You'd almost have to repeat a sample in New York City, in California, in Colorado, some other places. So when it says what's the population or what's the implied population, they don't really say, do they? So what do you think, since he published this in USA Today, what do you think he's thinking is the implied population? What?
Of the U.S. household.
Of the households in the United States. Yeah. Because that's just what people do, don't they? They just kind of make these big jumps. And what is the sample?
The 1,006
households that were surveyed. Okay, good question. Number 8. In 1936, did you remember reading this in history class or learning this in your history class when you were in high school, that the Literary Digest predicted that Alf Landon, the Republican candidate for president, would be elected president, when actually Franklin Roosevelt won the election.
Okay.
Do you remember reading about that in your classes? Because that's pretty historic event. Okay, now we're going to do some statistical analysis here. You are going to become the resident statisticians. In 1936, number 8, on the basis of a sample of 2 million voters, no wonder they made such a powerful prediction. They had 2 million voters. Selected from where?
Automobile owners and telephone subscribers.
And based on their sample of 2,300,000, Alf Landon wins the election. And it was so clear that they said he wins by a landslide. Okay. Did automobile owners in 1936, did automobile owners and telephone subscribers represent the population of America?
I don't know. Probably. I don't know.
Who would own a car in 1936 and have a telephone in their house?
Rich people.
white guys.
People with higher incomes.
Uh-huh.
So they surveyed the people with higher incomes in the United States and made a generalization about the whole population
Yeah,
and missed it.
that's funny.
By a lot.
Because the people who couldn't afford cars and telephones did not vote for Alf Landon. So apparently, is this fair to say, Alf Landon was the rich man's candidate? And and the rich people didn't get to choose the president. In our last presidential election, the intellectual elite in our society concluded that a nutcase businessman from New York City was running for president, opposing a Harvard-educated genius named what? Hillary Clinton. And the fact that she's the first woman running for president, that's going to give her an edge, right? Because all the women in America, I mean, what were the intelligentsia of our country saying? Because all the women in America will vote for her because she's a woman. I want to ask you ladies something. Is that an insult to your intelligence?
Yes.
Does that insult your intelligence to say, oh, so all the men are going to vote for the man and all the women are going to vote for the woman? That is not the way intelligent people vote, right? And I think, okay, now watch. This is where I happen to think that all of the intelligent people in the media and in Washington really do think that the rest of the nation is just dumber than stumps. And based on our ignorance, they can predict how we'll vote. And they still can't get over it. They are so shocked by what happened that they're still not recognizing that he's a legitimate president. Are they? I mean, it's just they're going ballistic about, I mean, I don't like the guy either. But say what you want, the American people said, this is the guy we want to be our president. Now, you say, how could they do that? Okay, now we start discussing politics. Well, how could we do that? Because they had two choices. Is this fair to say? They had two choices and neither one of them was a real good choice. So I think the history of America is that when you have two bad choices, you pick the lesser of two evils. That's just kind of how we default in our nation. If we don't like either candidate, then we say, well, I'm going to vote for, I'm not going to not vote because that's what makes our system work, so I'll vote for the lesser of what I think are two evils. And the intelligent elites in our country thought even at that level he'll lose because he's more evil than she is. And the American people said, see why they're so angry about this whole thing? Because intelligent people can't believe. In fact, I really think that intelligent people, the intelligentsia in our society, really believes that it's time to change the system because the average person in America isn't smart enough to make a good choice. So now we have to change the system so we can keep the masses from leading our country into destruction. When in fact, who's the most dangerous element in our society that could lead us as a nation into destruction? The intellectually elite who think they ought to rule the world.
Mm-hmm.
That's my humble opinion.
Mm-hmm.
You go, you're not supposed to bring politics in the class. Well, when you have a problem that brings it up, and old Alf Landon lost, and the Literary Digest just didn't get it because they were surveying all the rich people in the country and didn't even know they were doing that. Or they were assuming that only the rich people who have phones and drive cars will go to vote.
Mm-hmm.
When everybody did. So what was the population for number 8? Okay, who's going to vote in the election?
Everybody?
Will everybody vote?
Probably not.
What do you have to do to be able to vote in the next presidential election?
Have to register to vote.
You have to be a registered voter. So if they wanted a good sample, what should they have picked for their 2 million people?
Registered voters.
They should have gone to the registered voter list and randomly selected 2 million people across the country from the registered voter list. And they didn't.
Mm-hmm.
And that's what messed up their findings. What was the sample?
That's funny.
Was the sample a random sample?
No.
Okay, it wasn't a random sample of the population, was it?
Mm-mm.
Because it was, even if it was a random sample of the people who owned cars and had telephones, it wasn't a random sample of the population. And I don't even know if how did they get their 2,300,000 voters? It says selected from automobile owners. And see what I say is, was it randomly selected from automobile owners and telephone subscribers? Or did you do your, watch this. So what if you surveyed who's going to win the next election, and your survey was made in New York City and California? Because that's where the 2 largest populations are in America. So we'll get our best readings from those 2 places. Do you know anything about the politics of New York City and California? Whatever they find, it's not going to represent the masses of America.
Oh, they're leaving out a severe portion called Texas.
And why don't they survey us in the heartland? Because we just don't really count. Or shouldn't. Isn't that sad?
Mm-hmm.
I mean, it's just so sad that they treat us that way. Well, that's life. Okay, number 10. An important concept in the manufacturing process is quality control. Products are inspected during production, and the equipment is adjusted to correct any defects. Since not every product can be examined, how would you draw a random sample of 10 of the next 50 CDs that are coming off of the assembly line? That's on page 782. How would you draw a random sample of 10 of the next 50 CDs? Okay, there's 3 things you would do. You would number some cards 1 through 50. take some little pieces of paper and number them 1 through 50. The second thing you would do is shuffle those cards. Put them in a box and shake them up and mix them all together. What's the third thing you would do? We want a random sample of 10 out of the next 50, out of 50. So what would we do with that box of 50 little cards with numbers 1 through 50 on them? We would reach in the box and pull out how many of them? If I want a random sample of 10, I would pull out 10 of them. And then of the next 50 that come off the line, those would be the 10 that I pull off to see if they're defective. That's the process. Drawing a random sample is a 3-step process. You make sure, the first step is, you make sure that everyone in the population has an equal chance of being selected. That's why you put them in a box and shake them up and then pull out 10 of them. The second thing is you shuffle them, because if you just wrote 1 through 50 on a card and took the top 10, what would you have? 1 through 10 instead of a random sample. It wouldn't be random. So you shuffle them or shake them up, and then the third process is you draw out 10 of them.
Problem 11 says that we have to make a frequency distribution. Yeah. How would we do that?
Well, let's just do it right now. Let's just make a frequency distribution. Let's just work problem number 11. 30 students were asked to list the television programs each had watched during the preceding week. And then from this list, the number of hours each spent watching television during the week was calculated. And here are the results. So it went from what? 0, 1, 2, 3, 4, 5, 6. Look at that list of numbers. What's the highest number?
6, 7, 8.
What's the highest number in that list?
It looks like 14.
10, 11, 12, 13, 14. Okay? Does everybody agree with that? We've got 0 through 14.
Yeah, but we have repeats of some of them.
So, this is the first step. We're making a frequency distribution. For the first step is list all of these numbers. Then what's the second step? Now, would you rather look, I want you to make a decision. Would you rather look across at a row or would you rather look at a column? Would you rather go 1, 5, 4, 7, 10, 8, 2, 3, 9, 6 or 1, 6, 0, 5, 12, 3, and 4, 8, 5?
Let's go like a row.
Let's go like a row, okay? So I've got them all listed here, right? So now this, and this is tally. So what's the first number in the row? The first number in the row.
In the row?
1.
Okay, so watch what I have. What's the next one? After 1?
Oh, sorry. 5.
You guys got to help me. What's the next one?
4.
What?
4.
What's
7,
the next one?
7.
10.
Okay, you've given me 1, 5, 4. You guys aren't helping me do this.
You just said.
What is the next one?
7.
7. 1, 5, 4, 7. What's the next one?
10.
What's the next one?
8.
2. 3.
9. 6. 6. 12. 8. 14. 3. 4. 8. 7. 2. 1. 0. 3. 5. 8. 10. 12. 0. 15. Oh, 15.
Oh, we need another one here. 15.
15, 1, and 4.
Everybody see what I did?
Yep.
See how you go through the list and make tally marks?
Uh-huh.
Then you make this frequency thing. 2, 3, 2, 3, 3, 2, 2, 2, 4, 1, 2, 0, 2, 0, 1, 1. All right?
Mm-hmm.
Now, turn back to page 783. Does that look like table 12.3?
Yeah.
Yeah. And that's how you make one.
Okay.
So we've just done A. And what was this? This was hours, tally, and frequency. So now, what does B say? What's the most frequent number of hours watched? And the answer is? Look at your frequency chart.
8.
8.
That's a lot of hours.
How many students watch television more than 10 hours? More than 10.
4 did.
More than 10. Not 10, but more than 10. 12, 14, and 15. That would be 4, wouldn't it?
Mm-hmm.
How many students watch television 5 hours or less? 5 or less. 5, 10, 15. Everybody see that? And see, I can't answer the questions until I've built my frequency chart. Everybody see how to do these?
Yeah.
What percent of the students watch television more than 7 hours? More than 7 would be what?
Let's see.
5, 6, 7, 8, 9, 10, 11. They didn't say how many, they said what percent. 11 out of how many students?
30.
So 11 out of 30. What percent would that be?
Let's look it up.
Get my little calculator out.
It's 36%.
11 divided by 30 equals 0.36666. So what percent would that be?
36.
Would it be 36 or 37%?
Oh, 36.7.
Or 37.
If it's to the nearest tenth, it would be 36.7.
Yeah.
If it's to the nearest percent, it would be
37.
37%. So, now let's make a histogram. Well, how cool is this? Problem 12. Let's make a histogram for the data obtained in problem 11. So watch how we make a histogram. Hours. See these hours? What would this be? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? Then we go up the side. And we do what? What do we do now? Let me erase this here for a minute and go. Now that we're making a histogram, hours, and this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Say, why'd you put the numbers in between? I'll show you. Now, what is it we're going up? What's going up the side? Frequency. And those numbers would be from what? 0
to 15.
to what?
15. Or 0 to 30.
What's the highest number here?
15.
To 4.
Frequency. Frequency.
Oh,
What's the
frequency.
highest number?
4.
1,
Yes.
2, 3, 4. Okay? So, we start here and do what? At 0 hours, the frequency was what? 2. Agreed?
Mm-hmm.
At 1 hour, the frequency was
3.
3. At 2 hours, the frequency was
2.
2. At 3 hours, the frequency was
3.
3. Everybody see what's going on?
Uh-huh.
At 4 hours, the frequency was
The same.
what?
Same. 3.
3. At 5 hours, the frequency was
2.
2. At 6 hours, the frequency was
The same.
what?
2.
2.
And it's the same for the next one.
At 7 hours, it was 2.
Uh-huh.
At 8 hours, it was,
4.
whoa.
A long time.
At 9 hours, it was 1. At 10 hours, it was 2.
Imagine.
At 11 hours, it was 0. At 12 hours, it was
2.
2.
Uh-huh.
At 13 hours, it was 0.
What is that existence?
At 14 hours, it was 1.
I don't watching TV for free.
And at 15 hours, it was 1.
You're gonna
And
say-
guess what I just made? A histogram. That's called a histogram. Okay?
Yeah.
So do you see the technique? I take whatever it was I had here and put it across the bottom. And then I take my frequencies and put them up the side. And then make a little picture. Now, there's one more thing you have to learn. And it's on page 791. It's a frequency polygon. Now watch how I make a frequency polygon from this thing here. Where was 0? At 2. I put little dots right in the middle of each one of these. Remember, that's 0. That one's 0. And then come back down here again. Okay, so I start here, and I need a ruler. So I start here, and I go. Can you see green okay, or should I use red?
I can say green.
Can you see it?
Mm-hmm.
I'll use red for fun. Okay, so
Okay.
I go from this green dot to this one, 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 and from this green dot back to this one. Now, isn't that beautiful? And the reason they call it a polygon is because if I made a red line across the bottom, see, I would have this nice little polygon shape. And that's how you do every one of these problems. Except there's one more that we should look at. Problem number 20. Now, what does problem number 20 tell us? Now, is it okay for me to erase some stuff here?
Yeah.
You've got, the other day we were working something, and Celeste goes, I said, you know, if we just had a picture of this, she goes, aha! And so she just came up here with her little phone and snapped a picture of it. So does someone want to snap a picture of this before I erase it?
Yeah, I do.
Okay.
I mean, it's on the video. So
But it might be easier to see with your picture.
Sure.
Cool.
I just love modern technology. This stuff is so cool. The other day, the computer in the Langmaid room where I teach math 1, wouldn't let me put my tablet up there, so I had to go up and work from the whiteboard. And I felt like I was in horse and buggy days. Once you get used to a tablet. Okay, so let's do number 20. I'm just going to move this over here so I can see the numbers. 20 apprentices were asked to measure the diameter of a steel rod with a micrometer. You know what that is? It's a little thing that you put over a rod and you screw the handle down until it touches, and then you look at the dial to read what the diameter is of the rod. It's just an instrument to measure things with. And these 20 students are in trouble because look what they came up with. How many different measurements? 5, 10, 15, 20. Oh, they're not 20 different measurements. Some of them are repeats. What's the smallest measure? Let me put black up here. It's easier to read.
0.241.
0.24 what?
Wait.
Is the smallest measure?
0.6.
0.24.
Oh no, there's 1.5.
5.246, 0.247, 0.248, 0.249, 0.250, 0.251, 0.252, 0.253. How far did it go?
2.254.
54. Is that the last one?
I
Yeah.
think so. Yeah.
Now, see what they want us to do? Make a frequency distribution. So here are the measurements, and here's the tallies. Now you have to give me the tallies, people. Make this quick.
0.254. 0.245.
0.254,
And
0.245. Then what?
0.253.
Okay,
0.251.
okay,
0.249.
Okay.
0.252.
Okay.
0.251.
Okay.
0.252.
Okay.
0.247.
Okay.
0.251.
Okay.
0.250.
Okay.
0.247.
Okay.
0.251.
Okay.
0.249.
Okay.
0.246.
Okay.
0.249.
Okay.
0.250.
Okay.
0.248.
Okay. Everybody see what we're doing?
Point.
See the process? So now we've got the tallies. Now what's the
There's
frequency?
2 more numbers, Dr. Bud.
What?
There's 2 more numbers.
Oh.
0.249
Okay.
and 0.253.
0.253. All right. So now the frequency would be 1, 1, 2, 1, 4, 2, 4, 2, 2, 1. You follow what's going on?
Mm-hmm.
So now when it says for number 20, make a frequency distribution, we just did it, didn't we? That's the frequency distribution. The measurement, the tally, and the frequencies. Then, what's it say next? Oh, it doesn't say make a histogram. If it said make a histogram, we would do this thing here. You follow me? But now it's just asking some questions. And that's why we're doing this one, because it has a little bit of a different twist to it. So, what single measurement has as many measurements above it as below it? How many measurements were there? 1, 2, 4, 5, 9, 10, 11, 15, 16, 17, 18, 19, 20. There were 20 measurements, right?
Yeah, 0.251 has as many above it as below it.
So 0.251 has 6, 7, 8, 9,
Oh,
10,
oh,
11.
I didn't know it meant all of them.
And,
Never mind.
no?
That was
What
wrong.
measurement has as many above it? We need 10, don't we? 4, 5, 6, 7. 4, 5, 6, 7, 8, 9.
6, 7,
4,
8,
5,
9. Yep,
6, 7,
that's it.
6, 7, 8, 9. Is that
That's
it?
right
Yeah.
there.
So right here, it's 0.250. Okay? Now what percent of the measurements are between 0.249 and 0.251? 0.249 and 0.251. How many measurements were between 0.249 and 0.251?
4, 8.
10? Is that right?
Yep.
4 here, and 2 here?
Yep.
So what percent would that be? 10 out of 20? Right? Total of 20? So that would be 50%. Agreed? So what does it say next? So what would you take to be the best estimate of the diameter of the rod? I mean, the rod's the same diameter, and all the and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these novices, what are they called? Apprentices. Somebody needs to teach an apprentice how to read a micrometer. Somebody's pretty sloppy with reading their micrometers. But if you had to look at this information and say, what's the best estimate of the actual diameter of the rod? What would you say?
0.250.
0.250. Okay. And that makes sense, because when they're making rod and sending it out of those little hot iron things that make it, would they make a rod that was 0.250 or 0.249 or 0.251?
Probably 0.25.
Probably 0.250. But it could be that when they're making rod 0.250, that the tolerance the margin for error is 1/1000th of an inch. So these guys might be measuring a piece of the rod that is within the tolerance levels,
Yeah.
but the rod's supposed to be 0.250. Oh, now you're learning something about how statistics is used to better understand the world in which we live. And that's it. Everything from here on out, like problem 28, the following numbers represent salaries. So what do? I make a column called salaries and I list them. You follow me? And I list the salaries, and then I make a frequency distribution. So I make tally marks, then I make frequencies. Then what do I do for 28? Make a histogram. So I draw a picture. And then after I get my picture drawn, I make my little red dots and connect the dots. You follow me? And that's called a polygram.
Well, what number do you want us to stop at?
Oh, let's see. Stop when you get to 33. And this stuff is so much fun. Isn't it? Okay, now maybe it's not fun yet, but do you see the value of it? And do you see what's going on?
I like the idea of statistics.
Good. Because see, this whole chapter is going to have to do with, okay, as an educator, you're going to have to mess with statistics. And this, Celeste says, you're going to have them in your classroom with testing and stuff. And this whole chapter is going to give you the information that you need to understand statistics when you talk about it in the future. When it comes to the classes where you discuss statistics, you guys are going to be the smartest people in the room by the time we finish this chapter. I mean, if you look at the rest of the topics we're going to cover, we do standard deviation. We learn to do all that stuff. This is so cool. This is so relevant to an education major. I just love helping you guys become expert teachers. And then someday when you go to grad school and you're surrounded by people who have no idea what's going on when they discuss statistics, you'll go, here, let me explain it to you. And you'll explain it to them and they'll go, how do you know this stuff? And then you smile and say, I did my undergraduate work at Calvary University. It's so cool to be able to say that.
Dr. Bono.
Yeah.